graphs. So the topic of the questions that we are going to see is graphs. Now we need to see what we can understand or what we need to know in the graph based questions. So for that we need to know how many types of graphs are available. There are total 3 types of graphs are available according to the 2024 NEET syllabus. One is position time graph. Position time graph, otherwise also called as displacement time graph, which I will represent it as ST graph. Number 2, you have velocity time graph. Number 3, you have acceleration time graph. So you just need to know the basic information in this. What do these graphs give you? First, displacement time graph offers you velocity from the slope. So slope gives velocity. Suppose if it is a distance time graph, then the slope will give you speed. And slope, how do you calculate slope? You can either calculate, if it is a curve, you can calculate the slope using tan theta. You can write it as y2 minus y1 by x2 minus x1. This is for average motion. If it is instantaneous motion, you can write the slope tan theta is equal to dy by dx. On the other side, you have velocity time graph. In the velocity time graph, we will be getting slope gives acceleration. For us, slope gives acceleration, and also area under the VT graph or velocity time graph gives displacement. From the same velocity time graph, if you want to find distance, all you need to find is magnitude of the area. Magnitude of the area gives distance. So these are the 3 aspects we can get it from velocity time graph. So to find slope, the slope equations are this. You can use it wherever you are finding the slopes. The last one, acceleration time graph. In acceleration time graph, only one value you can get, that is area gives change in velocity. So I repeat this part. Position time graph, in that slope of the position time graph gives us velocity. Slope of velocity time graph gives acceleration. Area of velocity time graph gives displacement. Magnitude of the areas will give distance. In acceleration time graph, area will give you the change in velocity. One more thing you can know about the slopes, that is, if theta value is 0, it means slope 0. If theta value is greater than 0 but less than 90, slope can be taken positive. If theta value is greater than 90 but less than 180, slope can be taken as negative. Okay, so based on these quantities, we will verify some questions. Particle shows a distance time graph or time curve as given in this figure. Maximum instantaneous velocity of the particle is around the point. So in this graph, how do you verify the instantaneous velocity? I told you distance time graph, if it is a straight line motion, which is not especially mentioned over here, if it is a distance time graph or displacement time graph, instantaneous velocities are always obtained by drawing the tangent at that particular point. And so for example, if this is the graph and this is the curve that you are having, if you want to get the velocity at this particular point, all you need to do is draw the tangent. Now whatever angle the tangent makes, that tan of that particular angle should give you the slope at that point. So let's draw tangents for all the given 4 points and see which one has maximum angle. At point A, it's almost 0. At point B, there is some. At point C, this is the tangent, and at point D, this is the tangent. You can verify at point B and C. At point B, if the angle is theta 1, and at point C if it is theta 2. we can clearly understand over here that theta 2 is greater than theta 1, which means angle over here is greater than angle at point B. So therefore we can directly say slope at point C is greater, and distance time graph or displacement time graph, slope will give us the velocity. Therefore at point C the velocity is greater, right? Let's see the next question. Displacement time graph is given of two moving particles, makes angle 30 and 45 degree with x-axis as shown in the figure. The ratio of their respective velocities is. It's a pretty straight question. We know it is a displacement time graph, and in a displacement time graph slope will give us the velocity, and I told you slope should always be measured as an angle of the tangent or an angle of the line with the positive x-axis. So here two values are given, two particles. Let us say this is particle A and this is particle B. You can consider it over here. Particle A slope is 45 tan 45 degree and particle B slope is tan 30 degree. So with respect to A and B, I mean A is to B, if you are taking, it is just about tan 45 is to tan 30, which will be 1 is to 1 by root 3, or you can write it as root 3 is to 1. So please be sure about these options. Option C and option D both are in the ratios of 1 is to root 3 and root 3 is to 1. So just make sure with what they are asking, ratio of their velocities. That means they have given it in the order of 30 and 45. So with respect to 30 and 45 ratio, if you take, the answer should be 1 is to root 3. I have taken it in the order of 45 to 30. That means A to B. They are asking B to A, 30 to 40. So the answer will be 1 is to root 3. I am saying this again. They have ordered in the answer was asked in the order of 30 degrees and 45 degree order. So I took in the solution 45 degree and 30 degree order. So you just reverse that. So the answer will be opposite of this. That will be 1 is to root 3. Let's see another topic. Instantaneous or variable accelerated motion. So far what we have done is constant accelerated motion based questions. What if the acceleration is not constant? Then how can we handle the questions? Well, we need to handle those questions by using little bit quantities like differentiation and integration. So I'll give you the basic gist of this instantaneous motion, through which we can go for few numericals under it. So if you have velocity, or let's start with displacement. If you have displacement as a function of time, from this to get velocity, you just have to differentiate the displacement with respect to time. If you want to get acceleration from this or from the displacement itself, either you double differentiate the displacement or you simply differentiate the velocity vector. Similarly, if you have velocity as a function of time, then you can get acceleration by differentiating the velocity with respect to time. On the other side, if the velocity is given as a function of position, then acceleration can be calculated by first differentiating the velocity with respect to position and then multiplying this differential with the velocity itself. So these are the differential formats, and you will go in this order. That means if displacement is given and velocity is asked, and velocity is given, acceleration is asked, you will always go in the pattern of differentiation. So differentiate displacement, you will get velocity. Differentiate velocity, you will get acceleration. If you want to come in the reverse direction, in other words, I'll just remove this part. If acceleration is given as a function of time and you want to find velocity, so you can use the integral method, that is integral dv is equal to, first write acceleration in its differential format. That means acceleration we can write it as dv by dt. So this we can write it as dv by dt, that means A integrate with respect to dt. You will go in the differential integration method. In the reverse, if velocity is given as a function of time and displacement is being asked, then to to get the displacement, you'll integrate the velocity with respect to time. So if you are going in the reverse order, acceleration is given, velocity is asked, velocity is given, displacement is asked, you will use integrations. If you are going in the forward order, displacement is given, velocity is asked, velocity is given, acceleration is asked, you will go in differentiation order. Okay, you need very basic formulas to solve the questions based on this. Mostly, if you just remember what is the differentiation of, what is the differentiation of x to the power n, and formulas like this, and basic differentiations of sine theta, which is cos theta, and cos theta, which is minus sine theta, that should help you to solve majority of the questions in this NEET pattern. Let's see some questions based on this. First question, in the instantaneous motion, particle moves a distance x in time t according to the equation x is equal to t plus 5 whole to the power minus 1. So let me write that equation over here. X is equal to t plus 5 whole to the power minus 1. Then the acceleration of the particle is proportional to. So we know position is given as a function of time and acceleration is being asked. So it is in the forward order. That means we need to use differentiation. So first differentiate position with respect to time, get velocity. This is like x to the power n. So the answer will be minus 1 into t plus 5 whole to the power minus 2. X to the power n differentiation is n into x to the power n minus 1. Then, so this is the value for velocity. Now if you differentiate it further down and you see the acceleration part, acceleration further if you differentiate velocity dv by dt, you will get the value here as 2 into t plus 5 whole to the power minus 3. So we got acceleration, velocity, but what we have been asked is acceleration of the particle is proportional to, and you can see the options are given in terms of velocity, distance, like that, which means we need to verify once we convert acceleration this t plus 5 in terms of x and t plus 5 in terms of v, what answers can we get. So for that, let's just verify this part clearly. So in here I will write, so we can write t plus 5 as one by x. So you can take this as 1 by t plus 5 and you can take it to the other side, and if you bring x to the right hand side, it will be 1 by x. On the other side for velocity, we can write t plus 5 whole square is equal to 1 by v, or t plus 5 is equal to, or I can just erase this square over here and make it as a root in this place. So this is what t plus 5 we can replace it as. Now let's just substitute in this acceleration and we'll see which one will fit the answers. So if I take it as t plus 5 as x, so that means I should write it as 1 by x, or I should get it as a is equal to 2 into 1 by x to the power minus 3, or acceleration directly proportional to x cube, distance cube. But I don't think that answer is there. Distance is given to the power minus 2 and distance is given to the power 2. So not. Let's check with the velocity. So if you check with the velocity, acceleration can be proportional to t plus 5 can be written as 1 by v, 1 by root v. So that will be 1 by v to the power 1 by 2 whole to the power minus 3. If I bring it to the numerator, it will become minus 1 by 2. That means we can write it as v to the power 3 by 2. And we have the answer as option A, velocity to the power 3 by 2. I repeat the solution over here. You differentiate it first, get the acceleration, then the velocity, the accelerations are given in terms of velocity or distance. So you better get the value for t plus 5 in terms of x and v separately. Substitute those things over here, you shall get the value of acceleration in the format or in the proportionality of v to the power 3 by 2. Okay. Let's go for the next slide. So the next question in the variable accelerated motion is motion of a particle in a straight line. This is the position display as given as a function of time. They are asking us to find the retardation of the particle when its velocity becomes 0. So we need to find the equation for retardation, that is another word for acceleration, which is slowing down the object, especially when velocity becomes 0. So let's first differentiate this equation to get both velocity and acceleration equations. So this is the position, you differentiate this to get the velocity. So differentiation of constant, that will be 0, for 12t it will be 12, and for minus 3t cube minus t cube it will be 3t square. That's the velocity, and the acceleration of this will be 12 part will be 0, and that will be minus 6t. So we got the equation for acceleration, and since it is having a negative sign, we can also term it as a retardation. So but this is a function of time. We need to know at what time velocity is becoming 0, and then if we substitute it back, we will get the answer. So you take the velocity equation, put v value 0. How much will we get? If v is taken 0, 12 minus 3t square, or 3t square is equal to 12, that will be, t will be 2 seconds. So if you substitute 2 seconds back in this acceleration or retardation equation, that will be minus 6 into 2, that will be minus 12 meter per second square. Since in the question they have already mentioned it as retardation, you don't have to look for negative sign in the options again. Straight away you can mark option D as the correct answer. Next question. Two cars P and Q start from a point at the same time in a straight line, and their positions are represented by two equations. At what time do the cars have same velocity? So it's very simple. They have given the position as a function of time for car P and car Q. You just differentiate them, get their velocity equations, equate those velocity equations, we'll get the respective time. Let's do it. So for xp, you can see the xp equation over there. So I'll directly differentiate that. So we will get velocity of the car P as a plus 2bt, and if I differentiate velocity of the car Q, I'll get it as f minus 2t. They said at what time velocities of these two particles will become same. That means Vp should be equal to Vq, which means a plus 2bt should be equal to f minus 2t. So you take all the t's to one side, that will be 2t plus 2bt is equal to f minus a. T if you take it common or 2t if you take it common, your answer will be f minus a divided by two into 1 plus b. So let's just check which option is it. F minus a divided by 2 into 1 plus b. Option B is the correct answer for us. Next question. If the velocity of the particle is given as function of time and where AB are constants, then the distance travelled by them between 1 and 2 seconds is. You see, for the first time in our questions, velocity is given as a function of time and distance is being asked. That means we need to go in the reverse order, that is integration method. So let's see how to do this by integration method. Velocity is given as a function of time. Integrate this with in order to get the distance, write velocity in its differential format, that is ds, and it is moving in any particular direction, no, so you can write it as ds or ds by dt at plus bt square. Now just simply integrate this. ds is equal to integral at dt, or you can integrate as a overall quantity itself, integral at plus bt square dt. So this shall give us between the respective limits time, we will substitute the time directly between 1 to 2, and we can consider if you differentiate, there is no initial velocity, nothing else over here, so we can directly take between 0 to s. So s is equal to, substitute the values, this will be a, t integral will be t square by 2, so a by 2 into t square between the limits 1 to 2, plus this will be t square integral will be t cube by 3, so b by 3 t cube between the limits 1 to 2. If you substitute the values, eventually you will be having this will be t square, that's t cube. So this will be a by 2 into 4 minus 1, in other words 3a by 2, plus this will be 8 minus 1, so that will be 7b by 3. So yeah, option C is our answer, 3a by 2 plus 7b by 3. Next question.